My name is Ariel Noyman. I'm a PhD candidate here at the City Science Group, working in the last 6-7 years directly on the CityScope and many of the projects you're seeing here in the background. It's really a pleasure to start this workshop, hands-on introduction to CityScope. Before I start to explain what CityScope is, I want to explain why we actually need CityScope. We know that many of the challenges facing cities nowadays, whether it is immigration, climate change, pollution, congestion, they all basically change the way we live and behave in our cities. But the mechanisms for planning and decision-making in our cities don't really follow those notions. They're very much top-down in many cases. They tend to be slow-paced and not very evidence-based, more kind of the zeitgeist of the planning at that moment in time, but not necessarily answering the actual questions. And finally, even if we have some technology and some new tools involved in the processes, they're usually either too cumbersome, too complex, and the learning curve is too steep for a lot of people to get a hold of the tools, ending up with an architect standing on the shoulders of another architect just to move a toilet from one end to another. Within that realm, we're trying to develop CityScope as sort of an alternative new urban process in which we do engage technology, but not in a very top-down manner, but actually in a collaborative and open-ended sense. And we can talk more about that, but I'll just really jump quickly into what CityScope is and how we employ and deploy it over the past few years. I like to look at CityScope in four main sort of themes or categories. We look into urban insights, predictions, transformations, and consensus. Now, again, these might sound like big words, but I'm just going to go through each one of them and explain through a couple of projects what do we mean by each one of these segments. So when you talk about insights, we basically look back into what already happened in the city. That is, all the information we can gather from the existing or past state of the city. So we started, this is kind of the very early versions of CityScope, starting with observations on mostly the tactile parts of the cities, transportation systems, energy, wind, water, very kind of physical, carnal parts of the urban environment. But very quickly, we moved into views of what we call the urban dynamics, which basically how we see the city moves and behaves, and what we can learn from that. We did a lot of work using telecom data and some other ways of kind of sensing and understanding those urban behaviors, urban dynamics over time, and really understand what people do and observe the city. And just very recently, if you've been to the Andorra workshop this morning, we've been also looking into this in the context of COVID, so how we can learn from telecom data, the behavioral patterns of many thousands of people in the city, and what we can learn in the context of managing better the policies for COVID. Now, this looks backwards, so this is insights, but when we think about cities, we actually look towards the future. So how can we take those data and use them in order to predict the future of our cities? So we did some work in the past few years in terms of trying to predict different behaviors and different occurrences in the city. So predicting, for example, the mode choice of transportation in the city of Boston, considering a small change to an urban environment, as well as a very, very recent project we just completed in Champs-Élysées in Paris, looking into how changes to that very important boulevard in the city might eventually affect the behavior of many thousands of users of that boulevard on a daily basis. So really predicting using, in this case, agent-based modeling, how people might behave and act in this area. This is a good segue to talk about the third segment, which is transformation. So we talked about data and how we can use it to predict and model, but what we actually need to do in the urban environment is to transform the physical city. So how do we change? And I think this is really where CityScope shines, because CityScope is all about iterative, interactive, and collaborative urban decision-making platform, as you can see here from Andorra, really physically changing the city and seeing how those changes will affect the city. And I think this stands on the shoulders of many years of urban HCI research, of course, starting with the famous work by Sutherland here at MIT in the 1960s, all the way to the Berkeley Environmental System simulator, going to Roshi Ishii's around the Joseph, and of course Kent, or in urban modeling and simulation, leading all the way to the work we do today, which basically allowed us to interact with the city in real time, see the changes, and understand their impact while we are in a conversation. Very recently, and this is really kind of the last year or like year and a half, we've been converting a lot of these tools into the web. We didn't know the pandemic would come, but that was actually something pretty beneficial to do in the get-go, because we realized converting many of these tools to the web allowed us to deploy several different projects in the past years, well, during the pandemic, even though we couldn't, physically deploy any of these systems. We're going to touch on some of that today, but I just want to kind of throw it here. The last thing is consensus. And again, I'm not going to talk about that too much today because this is really not the focus of the project. But consensus is basically how we bring this whole thing together, how we take the data, the predictions, the transformations, and eventually create a consensus between us and the communities and the decision makers. So we had a few, I think, leading projects in this context, the design of the Boston BRT with the Bar Foundation and the City of Boston, basically a basket of different tools which we have deployed in order to engage the communities here in the City of Boston and understand what will be the impacts of bus rapid transit changes to the city. And the I guess, probably most famous project we did in the context of collaboration and consensus, our refugee housing project in the city of Hamburg, where the city asked us to help them find housing for tens of thousands of refugees emerging from North Africa and the Middle East. Basically, again, deploying those CityScope platforms in the city of Hamburg and engaging hundreds of community members in an effort to find housing for these refugees all over the city. A project that was successfully launched in Hamburg, but now is being deployed by these different entities around the world. The last thing I would say in this kind of grand introduction is that a big part of both of this workshop, but everything we do, is to deploy these tools and to see them being used in different places around the world. So some of you might be familiar with this map of the different collaborations we have. Our move to deploy and build CityScope in an open source manner also brought many of these dots on the map to engage physically with the CityScope platform. I think every city that you see here, or almost every city, has or had a CityScope in their repository, and that's something we really want to see as well emerging from this workshop and from any other collaboration, how we can see those tools moving forward. The idea is not that we build them and others use them, but it's all of us building them together, all of us deploying them, all of us improving them, and making the best out of it. So up until now, that was sort of the hand-wavy, high-level kind of introduction to CityScope. What I want to do in the next couple of minutes is just to go under the hood and talk about how CityScope is constructed. So the three major kind of aspects of the platform is what you're seeing here. We have some kind of an input on the left side, some kind of an output on the right side, and something that computes in between. So the input could be anything. We can engage CityScope through a Lego platform or through a computer or any other UI. The output can also be anything. It can be a visualization on a screen, it could be projection on a table, and it could be an Excel sheet that is propagated by data. What's important is in the middle, we have this moment of taking the interaction, converting it into some kind of a representation. So a much more complex version of that same diagram is what you're seeing here on the top. Everything in purple is an input. That is how we interact with the CityScope platform. You can see different versions. We can interact with a physical Lego through a Python scanner. We can have a roboscope, which is currently being constructed, or just have a computer with a screen and a mouse. What's important is that all of that leads into this box, which is called the CityScope grid. The CityScope grid is a virtual computational representation of different inputs to the system. On the right side, and I'm skipping the blue part, on the right side, you're seeing the different potential outputs. Could be projections, monitors, portable, it doesn't really matter how we eventually visualize. The focus of today is on that middle part, where we take the input from the CityScope grid and throw it onto CDIO in order to be computed through those modules. What do I mean by that? CDIO is this cloud thing in the middle. Basically, I like to call it a 1920s operator because its role in life is to take data coming in from the grid, distribute it to the different analytics modules you're seeing here, and then when they are done, deploy that back into the output system on the right. So a couple of years ago, I started to work with Ronan on that idea of really distributing those analytics modules outside of the system. So making them standalone, having them completely agnostic to the rest of the system. And we built a few of these modules, and other researchers, of course, expanded them. And we have work done, very nice work done in Hamburg now on some of these modules. But then Chris, when he joined our group very recently, actually, and joined the CityScope team, found that the connection between CDIO and those modules is something that is really, really necessary. So basically, this entire workshop today is about that arrow, that small arrow between the cloud and the different modules that you are seeing there. But despite being small, I think it's actually a very, very important connection because all of that data that moves between the system is kind of building on top of that arrow. So if that all was very overwhelming, I just want to very quickly show you how do we usually start a CityScope project. Where do you start? So we've been working in the past few months to build a system that makes it very easy for everyone to start their own CityScope project, really with hopefully, let's say, 2 clicks. So for that, we build a tool that we call the CityScope.js grid editor, which is allowing you, if you go to this website up there, allows you to basically create a simple introduction to a grid or a simple grid and put it immediately on CDIO. So virtually, if you don't change anything in that tool, with 2 clicks, you can end up with your own CityScope endpoint. That CityScope endpoint is then accessible through that link up there. So assuming you call that endpoint, let's say table, you'll just have your own CityScope living in that endpoint up there. Of course, what you're seeing here in this video would not immediately apply to your table because most of these analyses and visualizations would only live there after you deploy a module, which is the purpose of the workshop today. But that's really kind of the base. The last thing I would say is that we also were motivated by this workshop to recreate our documentation website. So this is a lot of work that everybody in the CityScope team was doing in the past few months, kind of documenting and writing out a lot of the ideas that I explained today. So feel free to also go to cityscope.media.mit.edu and either read and understand or comment and ask us to improve our documentation. We can always do that. So that's for me. Thank you very much.